In this video, we're going to talk about absolute and local extrema. We're just going to talk about the definitions, what they are, and show a few examples. And then in the later videos, we'll talk about how we find those things. Okay, so first off, the absolute extrema, we have the absolute minimum and the absolute maximum. So the number f of c is called the absolute minimum of f on some interval I, right? If it's the smallest y value of any point on the graph of f of x on that interval I. Okay, and the number f of c is called the absolute maximum of a function on some interval I if it is the biggest y value of any point on the graph on that interval I. Okay. All right, so let's take a look at some examples of those things. All right, so first off, we have the function f of x equals 4x over x squared plus 1. The domain of this function is all real numbers. It's defined everywhere, okay? And the absolute maximum occurs right here at this highest point on the graph. And so the y value of that highest point is 2, right? So 2 would be the absolute maximum of this function on the entire number line, okay? And then the absolute minimum is down here, right, of all the points on the graph on the entire number line, okay? This is the one with the smallest y value, and that is -2. It's the lowest point on the graph, so its y value is called the absolute minimum, okay? So that's it on this one. All right, let's take a look at this function, g of x equals x squared. It's a pretty simple function. It has an absolute minimum right here. All right, so the lowest point on the graph, right, if I consider the entire graph, the lowest point is this point down here, and it has a y value of 0. Okay, so the absolute minimum of g, this function g of x equals x squared, on the entire number line, the absolute minimum is 0. Okay, so the smallest y value. And there is no absolute maximum of this function, right? This function just keeps going up and up, right? So there is no highest point on the graph. So there is no absolute maximum. So you don't have to have an absolute maximum or an absolute minimum. And this example shows that you could have neither, right? If I look at the function h of x equals x cubed, right? Then this function has no absolute maximum and it has no absolute minimum. So a function doesn't have to necessarily have to have either of those things. Okay. One final example on the absolute maximum and minimum is that the absolute maximum and minimum not only depends on the function, it depends on the interval that you're talking about. So if you look, right, I can restrict the function down. So this function j of x is the function x cubed, but I'm only going to consider this interval from -1 to 2. So if I only consider that interval from -1 to 2, right, it does have an absolute minimum. The absolute lowest point, if I only consider those, is down here on the end. And the y value there is -1. So the absolute minimum of this function on the interval from -1 to 2 is -1. And it also has an absolute maximum, right, up here at that right-hand endpoint. And you can see that the y value at that endpoint is 8. Okay, so it has an absolute maximum on this interval from -1 to 2. This is the same function that we were looking at before, right? But it's a different interval. In this example, right, we looked at all of the points on the graph, everything on the number line, and there was no absolute maximum and there was no absolute minimum. So, but if we restrict to some smaller interval, right, then there is both an absolute maximum and an absolute minimum. So it depends, right? The absolute maximum and absolute minimum depends on the interval also, as well as the function. Okay? All right. So the next idea that we want to look at is the idea of the relative or local extrema. I'll probably switch back and forth between those two words, local and relative, but they mean exactly the same thing. And this is a kind of a long-winded definition, but a local extrema, a local minimum, or a local max is not the absolute highest or lowest point of any point on the graph. It is the highest point or lowest point in some small area, right? Localized. That's why it's called a local max or a local min. So in some open interval around the number, the y value of that point on the graph is either the highest or lowest on there. So let's take a look at the graph again, and let's take a look at what the idea of a local max and a local min is. So let's look at this one first. Okay. So right here, if I take a look at this point, right, that point right here, this is not the absolute max, right? There's way higher points up on the graph right here. But if I only look at the x values in some small open interval here around whatever the x value is, minus 0.816, right? That is a high point in there if I only look at those x values in there. So while it's not the highest point of all the points on the graph, there's some small area here that if I only consider those points, that is the highest point on the graph. So that's called not an absolute max, but a local max. Okay. And then here on this one, this point right here is not the lowest absolute minimum, right? Point, because there are many points on the graph that are lower down than that point there. So it's not an absolute minimum, right? But if I only look at the x values in some small area right here, then that is the lowest point. So it's not an absolute minimum, right? But it is a local minimum. So this right here would be a local minimum, minus 1.089. We'll also say that this point is a local minimum point, or this one is a local maximum point as well. Okay? So the absolute maximum and absolute minimum are the absolute the y values of the absolute highest point on the graph and absolute lowest point on the graph, right? And local maxes and local mins are the y values, right, of the points that that are the biggest or smallest in some sort of small area of the graph.